Alright, and it's time for number 3. The pattern on this one is add 6 every time. And so my common difference is going to be 6. The initial value is the first number, which is 4. And we're going to write a recursive function, a sub n is equal to a sub n minus 1 plus 6. And then we have to write down the initial value, the starting point, which is 4. And there's our recursive function. The explicit one follows a similar form, but a little bit different. You're going to have 6 times n minus 1 plus 4. And remember, you're just basically, all the explicit ones for arithmetic sequences are the same. They look like this, you're just replacing those two numbers there. And now we got the explicit, you're going to plug in 15 to get the what the 15th term would be. Whoops. Which is going to be, if you do 6 times 14, you're going to get 84. And then you add the 4 there, which is going to give you 88 for your 15th term, which is the same as the function value of 15. Okay, so it's 88. Moving on to number 2, the common difference in this case is subtract 5, because it's subtract 5 every time. The initial value there is negative 29, so that's going to go there. Recursive function follows the arithmetic pattern, where every term is equal to the previous term. I would put plus negative 5, or just put subtract 5 there. That 5 is kind of hideous. And then my starting point, as in my first item in the sequence, a sub 1, is negative 29. So there's my entire recursive function. The explicit function, again, very, very similar to the last one, except you got negative 5 and negative 29 for your numbers. And so that's going to be the explicit one. To get the 15th term, you plug in 15. So you plug in 15. Write it down, write it down, write it down. You got to do negative 5 times 14, which is going to be negative 70. And you got to subtract the 29, which is going to give you negative 99 for your 15th term. Okay. Number 5, this has a different pattern. It's multiplied by 5 every time. And so this is a common ratio. Remember, you make a distinction between arithmetic and geometric sequences. My initial value is my starting point, which is 1. So my arithmetic sequence, every term is equal to the previous term times 5. And I'm going to write this one a little bit differently. I'm going to put the 5 in front. So it's 5 times the previous term. So every term equal to 5 times the previous term. And make sure you put down the starting point. So the first number in the sequence is 1, because that tells you where to start, and you can do the pattern from there. The explicit function, again, the geometric ones are a little bit more confusing, but you put your initial value in front, and then you'll have what you're multiplying by to the n minus 1 power. Okay, and the 1 in front really doesn't do anything, and so we really just have the function f of n equals 5 to the n minus 1 power. And if you want to get the 15th term, you just plug it into the function. You just take 15 and plug it in. So we got 5 to the 15 minus 1 power. So it's 5 to the 14th power, which is going to be a very large number. Like a really, really large number. 6, 1, 0, 3, 5, 1, 5, 6, 2, 5. Yeah. That is 61 billion. Wait, just kidding, I miscounted. 6,103,505,625. So that's, yeah, and that makes sense because 5 to the 14th power is just got a huge exponent. It's going to be a big number. And that's going to be up to 5 for now.